Hi everyone. Today we are going to talk about the product of powers property. Now, if we know some rules that we can use when we're working with numbers that have exponents, we can use that information to simplify our expressions. So we're going to get a couple of these properties. Today we're starting with what do we do when we have the same base with different exponents that are being multiplied together. So you can see we've got a general rule here, and it says if we can multiply powers with the same base by adding their exponents. If you take a look at this example to the right, 2 to the third power times 2 to the fifth power, well, if I think about what that is, 2 to the third power is 2 times 2 times 2, and then I'm multiplying that amount by 2 to the fifth power, which is 2 times 2 times 2 times 2 times 2. So we've got 5 2's there. Well, if I look at that all together, I don't really need these parentheses around these 2's. This is just 1, 2, 3, 4, 5, 6, 7, 8 2's that I'm multiplying together. So that's the reason why we just need to add those exponents when we are multiplying those two numbers together. So we have 8 2's, it's 2 to the 8th power, okay? A couple reminders for you as you're working. If you look at the directions, it says use the rules for exponents to simplify. Your final answer should be left in exponential form. So the good news is you do not need to write your answer in standard form. You can just leave it with the base and the final simplified exponents. However, you should not have parentheses, negative exponents, or zero exponents in your answer. And remember, zero exponents, anytime I have an exponent of 0, we know that that answer is always going to be 1. So 2 to the 0 power is 1. A negative exponent, let's do a review of that. Negative exponents, so if I have 2 to the negative second power, that's a little negative there, let's make it a little bigger. This turns my base number into the denominator of a fraction. 1 will always be the numerator, so I know that the 2 to the negative second power is really 1 over 2 to the second power, okay? All right, so let's take a look then at our problems. Number 1, 5 to the 6th power times 5 to the 2nd is really just going to be 5 to the 6th power plus the 2nd power. So we have 5 to the 8th power. Number 2, 2 to the 4th power times 2 to the 6th is 2 to the 4 plus 6, or 2 to the 10th power. And again, I'm just writing my final answer in exponential form. 8 to the 5th power times 8 to the 3rd, well, I'm just adding the 5 and the 3, so this is 8 to the 8th power. Number 4, here now we have one of our base numbers has a negative exponent with it, so we're still adding them. You can think of it as subtraction too. So 4 to the 10th power times 4 to the negative 6th is 4 to the 10th plus negative 6. Well, use your integers rules. You know that this is 4 to the 4th power. 10 minus 6 is 4, and we're done there. The next one, negative 2 to the 3rd power times negative 2 to the 7th power. Again, remember to use your parentheses here. Negative 2, and then we've got 3 plus 7 for our powers. So this is negative 2 to the 10th power. Now, if we remember, we have an even number that is our exponent, 10. So that means I have an even number of 2's. And if I know I'm multiplying a negative number an even number of times, I'm going to get a positive answer, because I know a negative times a negative gives me a positive number. So remember, we said we don't want to have parentheses. If you have an even exponent, you know you can take away that negative. This is really just 2 to the 10th power, and that's our final answer, because we know it will be positive. Okay, next one, 6. 7 to the negative 3rd Oh, that negative's kind of small. There we go. Plus 4. Negative 3 plus 4 we know is 1, so 7 to the first power, or just 7. Okay, because we know 7 to the, any number to the first is just that number. Okay, let's keep going here. Number 7, negative 9 to the third times negative 9 to the negative third. Well, we've got our base, and then we've got 3 plus negative 3. Well, we know those cancel out. So this is negative 9 to the 0 power. We know final answer, this is just 1. Okay, now 8. This is essentially kind of like a variable here where we see that little box for our exponent. It just means what would the exponent be in this case. So we know 5 to some power times 5 to the second power equals 5 to the third power. Well, we know we need to add our exponents, so that missing exponent has to be 1. Because we know 5 to the first power times 5 to the second would give us 5 to the third. Okay? So I'll put a little 1 up there. All right, next one, number 9. 9 to the 10th power times 9 to something power equals 9 to the 15th. Well, in this case, we know that that's got to be a 5 because 10 plus 5 is 15. So we know 9 to the 10th times 9 to the 5th equals 9 to the 15th power. Number 10. 5 to the 12th power times 5 to something power equals 5 to the third. Well, here I know I have to subtract. I'm getting smaller. I know 12 minus 9 is 3, so I know I need a negative 9 for that little exponent there. To prove that, I'm showing 5 to the 12th times 5 to the negative 9th would be 5 to the third. In this case, there was a question that came up. Yes, you can have a negative exponent here because we're working backwards. So I know before I said you shouldn't have any negative exponents, but here you're just filling in what's the exponent that will work. Okay, let's get back to some other examples where we already have the exponents. Negative 2 to the negative third power times negative 2 to the negative fifth. Well, we've got negative 2 as our base, and then negative 3 plus negative 5. That is going to be negative 2 to the negative 8th power. Well, I've got to think about a couple things. I have parentheses, and I have a negative exponent. So I'm going to get rid of that negative exponent. First, I know that this is going to be 1 over negative 2 to the 8th power, and I know that that power is an even number, so my answer is going to be positive. So this is just going to be 1 over 2 to the 8th power. All right, next one. 6 to the third times 6 to the fourth times 6 to the negative fifth. Well, in this case now, we're just going to add all 3 of these exponents. So I've got 6, and then to the 3 plus 4 plus negative 5. 3 and 4 is 7, negative 5. I'm going to subtract that, so I'm just taking 7 minus 5. So this is 6 to the second power. Okay, and we have 2 more that we're going to take a look at. 9a, negative 3 to the 5th power times negative 3 to the 4th power. Just negative 3. Let's add that 5 plus 4, negative 3 to the 9th power, or this will be, in this case, we have to keep that negative, so we know that this is going to be negative 3 to the 9th power. Another way to write this is you could do negative 1 times 3 to the 9th power. Both of those would work. Last one, 9b, negative 5 to the 3rd power times negative 5 to the negative 5th. So we'll add 3 plus negative 5. This is negative 5. And then 3 plus negative 5 is negative 2. So here's another case where we have a negative number and a negative exponent. This is really 1 over negative 5 to the 2nd power. And we know if we multiply negative 5 times negative 5, this is going to be a positive number. So it's really like 1 times 5 to the 2nd power. All right. That's our lesson. Thank you. Bye.